So area of circles and sectors. So something about a sector here. Let's pick on a special angle. Attempting to draw right there an angle of pi over 3. Okay, so pi over 3 is equivalent to 60 degrees. And if I don't write the units, and sometimes I get lazy or forgetful, if there's no units visible, you should assume it is radians, because that's the default measurement for angles of trigonometry. Although we've grown up using degrees, it turns out they're kind of arbitrary and not all that important mathematically. So pi over 3 is where I'm at right here. So that is, if we think about like a half of a circle, if I went another pi over 3 over here, and when I'm doing trig, these are the kinds of things my brain does. Another pi over 3 puts me here. Another pi over 3 puts me here. So if I think about this right here, I've drawn out one sector of a circle, another equivalent sector, congruent sector of a circle, and yet another congruent one, because I was trying to do a pi over 3 going around each time. So then this angle right here, use a different color from here to here, that's another pi over 3. And then this angle over here is yet another pi over 3. And so there's 3 of them in the top. In the bottom, there's going to be 3 more, right, if we continue this idea through. So altogether, there's 6 sectors of this size in the circle. Now, let's suppose this circle has a radius equal to 2. Now let's go 3. Be a little different. 3 is a nice number. The area of a circle, you might remember, is equal to pi times the radius squared. Right? So this particular circle has an area of pi times 3 squared. 3 squared is 9, so it has an area of 9 pi. If I just wanted the area of the first sector, where the angle of that sector is pi over 3, I know that there's 6 pi over 3s to get all the way around to the circle right there. So the area of this particular sector right here has to be 1/6 of the way around. Right? How do I get that 1/6? Well, pi over 3 plus pi over 3 plus pi over 3 gives me 3 pi over 3s or pi. And if I keep going, add another pi over 3, pi over 3, pi over 3, all the way around, right, I have 6 pi over 3s. So again, if I have one revolution, and I'm counting by pi over 3, which I was doing there, I have 6 of those pi over 3s, which reduces down to 2 pi, which we have hopefully stuck in our memories that, yeah, 6 pi, 2 pi, that's one revolution there. So now I just want 1/6 of that circle, which was 9 pi, and then I can clean that up. So 1/6 of the area of 9 pi, let's see, 3 goes into top and bottom, 3 goes into 9 3 times, 3 goes into 6 twice. So the area of this sector would be 3 pi over 2. And maybe this was centimeters. So the full area is 9 square centimeters, centimeters squared. The area of this sector, any one of those sectors, is going to be 3 pi over 2 square centimeters. And now I just want to think more about this 1/3 and the idea of a full revolution. Now, 1/3 was my angle, and generally when we're talking about an angle, we're going to use the Greek letter theta here. So the 1/6 I have here, picture-wise, I was thinking, well, that's because the angle I have, theta, goes into a full revolution, a full circle, and that is where my 1/6 came from. Okay, so let's check that off to the side. I kind of did it by looking at the picture, but I could just write out my angle theta divided by 2 pi. My angle theta was pi over 3. Divide that by 2 pi. What do we get? Well, if we multiply, when we divide fractions, we usually multiply by the reciprocal. So pi over 3 times 1 over 2 pi. The pi's kindly divide out. Thank you, pi. Goodbye. And then 3 times 2 in the denominator is 6. So there's that 1/6. So there's a kind of a arithmetic way to come up with the same picture way I did. Remember, in this class, pictures are worth a lot. So this right here is basically the fraction of the circle. And we did something like that when we were doing the arc length. So this right here is the fraction of the whole circle. That's what I have going on there. So if I take that fraction, multiply by the area of the whole circle, well, area of a circle is pi r squared. In general, right, this was my pi r squared right there, then this is going to give me the area of a sector, and we can clean it up a little bit. So let's see, what cleans up here? Well, I guess the pi's can divide out. Different color, so pi goes into pi once each. That's about it. So what am I left with? I'm left with, for an area of a sector, I have the theta, I have the r squared, and there's still a 2 hanging out in the bottom. So there is a formula for the area of a sector, which reduces down to the angle. Super important. What kind of angle was that? It was a radian angle. If you use degrees, it's a different formula. So it is the radian angle times the radius squared divided by 2. And that's the area. You can also get it by a picture where you just say, hey, what fraction of the way did I go around? Multiply that by the area of a circle. So again, the other way I thought about the area of a circle is I want to find out what fraction around the circle I went, and then just multiply that fraction by pi r squared. So what's going to happen is in this class, you're not used to radians yet. If you've never seen them before, you're used to degrees. And so we're going to want to convert between radians and degrees. And so that's going to be something common we'll do as we get used to them. And hopefully we'll do that less and less as time goes on. So quick note on that conversion. Radians and degrees. In math, we make conversion fractions a lot. I could spell conversion. And a conversion fraction just comes by knowing some relationship between whatever unit you're converting to and from. So key thing that helps me out is I know that 1 revolution is the same as 360 degrees, which is the same as 2 pi radians. Degrees, 2 pi radians. Other things, if we think about the circle, if we go halfway around a circle, that's 180 degrees. And half of 2 pi would just be pi radians. And that's a nice one to use because I can't really get simpler than pi without plugging it into a calculator, which we're going to avoid sometimes. So this is my conversion equation right here if I need to convert. So if somebody says, hey, they were doing some work and they measured 100 centimeters and I need to do some serious math with that, I need to know what does that equal in radians. And the trick is to just multiply by a fraction based on that relationship there. So 100 degrees, I need degrees to go away. So I multiply by a fraction with degrees in the bottom, radians in the top, so that the degrees cancel out. And I know that 180 degrees is the same as pi radians. So then I can get rid of the degrees, and the answer is whatever 100 over 180 is. I can reduce that. Let's see. That would be 10 over 18 or 5 over 9. It doesn't get much simpler than that. So that would be 5 pi over 9 radians. And then if I had to, I could plug that into my calculator. If I were going the other direction, if somebody gave me an angle that I'm not familiar with, like they said the angle was pi over 5 radians, and I'm having a hard time thinking, what the heck does pi over 5 radians look like on a circle? I'm more used to degrees. I could make that conversion by multiplying by a fraction where radians is in the bottom, so it cancels out and degrees is in the top. And I know that there's 90 degrees in a half circle and pi radians in a half circle. So now I can get rid of radians and turn it into degrees. The pi's kindly divide out here. And I'm left with 90 over 5. 5 goes into 90. How many times? Is it 18 times, I think? So that should be about 18 degrees. Sometimes the numbers come out nice. Sometimes they don't. Kind of depends. For example, let's do another one. If somebody said they had 1 radian, what does 1 radian look like in degrees? Is that a lot of degrees or a little degrees? Well, I just convert. So let's see, to convert to degrees, I put radians in the bottom. I put degrees in the top, and I'm thinking about a half circle, which, oh shit, I made a mistake back there. Did anyone catch me on that? Oh, you guys missed it, damn. All right, mistake. This is a half circle, half revolution. I called it 90 degrees up there. Ooh, Gary, so naughty. So that is an error, which we all make. That should have been 180 degrees, this pi radians. So then this should be 180 degrees there. And then this, I believe, would be 36 degrees. So pi over 5 radians is the same as 36 degrees. And we can check that on a calculator. Just a sec. Continue with this next problem. All right, 1 radian, we'll check this one out. Let's see, what do we know? Half circle, 180 degrees. Got it right that time. Pi radians, halfway around. And the radians divide out. Nothing to cancel with the pi. Multiplying by 1 is pretty lame, so I get 180 over pi degrees. And then 180 over pi, well, pi is about 3, a little more. 3 goes into 180, 90, so it should be a little less than 90. Wait, no, 3 goes into 180, 60, so it should be a little less than 60. Calculator time, since my brain's not doing arithmetic very well. We want to know what is 180 divided by pi, and we get about 57.3-ish, 30 if we went to 2 decimal places. Should be the same as 1 radian. So let's see, I'm going to go play with a program that lets me do that. GeoGebra, I think, is where I want to go. Lets me play with angles. Okay, so tools, more, somewhere here, remember, angle of a given size. Let me try that here. It says select a leg point, a vertex, and then enter the size. Okay, so a leg point, the vertex of the angle. So a leg point would be, say, out here. Vertex would be where I want to rotate around. Oops, why didn't that work? Didn't think I picked a point. Okay, that's because I hid my points. Let's show my points here. Okay, so I got a bunch of points there. And let's do that tool again, angle of a given size. So we're going to pick this as an endpoint. We'll pick this as the vertex point. And then we want to rotate around. Okay, it's given me degrees. So what do we say? 57.3. 57.3. And I'm going to go clockwise. And it's got the degree symbol. Okay. So that puts me over here. See that B prime there? So I'm just going to draw a little line through that for fun. Boom, boom. And we can zoom in on that some more. And I'm just going to keep doing that going around. So that should be 1 radian. So I'm just going to go around again with that same tool to see what happens. So there, rotate there. Let's go with the same angle. Puts me here. So there's 1 radian, 2 radians, which is about 57.3 degrees. Let's keep going. Here to the vertex. Again, 57.3. There's 3 radians, not quite all the way around. Okay, I think that's reasonable because pi would be, sorry, halfway around. Pi would be halfway around, which is 3.14. So this is about 3 radians right there. I'm going to keep going. Yes, 57.3, which is about 1 radian, puts me here. And do it again. 57.3, which is about a radian. So there's 1, 2, 3, 4, 5 radians around. And let's just double check where 6 radians takes me. 6 radians takes me just a little bit before there. So I'm going to draw that line in here for the 6th radian. And remember, a full revolution is 2 pi radians. 2 pi is about 6.28. So the remaining angle to get from F to B here on this circle or that circle is going to be about 0.28 radians. All right, so we're just about out of time with fun with trigonometry. I'm going to stop here. And here I am. So take a look at section 5.2 and start the homework, finish the homework for 5.1 if you haven't already. And if you get stuck on anything, definitely send me a note. There's always that message your instructor by the homework problems, and we will pick up on Monday with section 5.3 and any homework questions you have on 5.2. So unless you have further questions, happy